So today's lesson is about trig graphs, and we're going to start with a little bit of, going back in time and remembering some of the stuff. So we did a topic on trig earlier in the year, but to really focus on trig graphs, we need to know some basics. So let's do a couple of multiple choice questions. So I want to know, what graph is this? And if you think it's A, put an A in the chat. If you think it's a B, put a B. And if it's a C or if it's a D, I want to know which one do you think it is? So I see A's and B's. Okay, keep those answers coming. I love the enthusiasm in the chat. Feels like we're playing Who Wants to Be a Millionaire. Dum, dum, dum. Okay, so what I'm going to do is, I see there's definitely a lot of love for A and a lot of love for B. We're not quite sure which one is which yet. So if we think of these two options, we get y equals and y equals cos of two options. Now, if I look at this axis, there is a 0 over here, and I want you to put in your calculator and find the sine of 0. And I also want you to, sorry, the sine of 0 is 0, they're not a theta. And I also want you to put the cos of 0 in your calculator. And then I want you to try and decide if that helps you make a decision about which one do you think it is. Do you think it's A or do you think it's B? Because there was definitely A's and B's, but if you put 0 into the function, it might tell you something. Aha, Naomi has said sine of 0 is 0. And I think I agree with you. The sine of 0 is 0. And the cos of 0 is 1. And if I look at this graph over here, the cos of 0 is in line with 1. So that tells me something. It tells me that this cannot be the right one. And it's true that tan looks quite different. And so what is the correct answer going to be? Is it going to be B or D? Yeah, it's going to be B. Let's just do one more little check though. If I look at this graph, if I'm really correct here, I'm going to make a prediction. If I'm really correct, the cos of 90, if I look at this graph, should be 0. Put that into your calculator and give me a thumbs up if you get my prediction as being right. Give me a thumbs down if my prediction is wrong. And the reason I'm predicting the cos of 90 is 0 is I can literally see 90 over here is in line with 0. Okay, so it looks like we're all winning at life, and so B is the correct answer. So this shape of the cos graph, the highest value it seems to get to is the value of 1, and the lowest value it seems to get to is -1. And it seems to kind of go down, down, up, up, in the most basic. It seems to be drawn with like these pieces, and each piece seems to be 90 degrees. Sometimes we call it the step size, but it's fine. We'll get back to that later. Okay, let's have a look at this one over here. What graph is this one? It looks quite similar to the last one. This is a little bit sneaky. So it looks like It's not the cos graph, and most of us know it's not the tan graph. But I want to try something. I want you to put, the point that I'm going to look at is this 90 over here. So I want you to put in your calculator, what is the sine of 90? And what do you get? So the sine of 90 is 1. But if I look at this graph over here, the sine of 90 seems to be in line with -1, which is interesting. Let's go to Siyabonga. Siyabonga, what do you think is going on? Can you hear me? Can you hear me, Siyabonga?
Yes. A, sir.
You think it's A?
Yes.
Aha. Okay. I'm going to reply to you now in a moment on thing. So what I'm going to say is it actually can't be A, because in this graph, the sine of 90 gives you 1, but if I look at the graph, it's in line with -1. But let's go to Khotso. He might have something else to say here.
Afternoon, sir.
Hi. What do you think is going on?
It's none of this. It is
That's
none of these graphs. Because
yes,
this
how do you
graph,
know that?
Because this, when I punch in the sine of 90, it gives me 1. But on this graph, we have -1. So in my case, I think it is the reflection of A.
Yes. Well done. You know your graphs. So you even know what type of graph it is. Okay. So the truth is that if you had to put 90 into all of these graphs, if you put the sine of 90, if you put cos t, will give you -1, which is what you want. So however, the cos of 90 is 0, and the tan of 90 gives you an error. So none of these graphs actually match the one that's here. And so the correct option is D, but that was a tricky one. And I just want to show you the normal sine graph does look like. So let me make like this. And like that. So the normal sine down to 80, down like and up like that. And so the graph that is the red one is actually just the reflection of that graph. So what they, and also teach you to how let's see how we look on this side. Yeah. Okay, let me see if I can put my phone somewhere with better reception in case it's being difficult. You can tell me if it's being difficult or not. Give me a thumbs up if you understood what was going on there. Give me a thumbs down if you feel unsure. Okay, see, I think the reception was my side. So we'll slow it down for a second. Lebo, am I lagging for you, or just want to check?
No, it's fine now, Mr. Ace. I also thought
Okay.
it was my network.
Okay, yeah. All right, I tell you what, let's keep going with this, because today is all about getting more comfortable with trig graphs. We don't need to rush it in today. Today is our getting more acquainted. So what graph is this one? Is it A, B, C, or D? Okay, so this one, people are flying out the blocks here. The people have spoken and the people have said that C is the correct answer, and you're right, because the tan graph looks quite different. I'd love to know what is what stands out to you about the tan graph? What's a bit different, or tell me something interesting about the tan graph now that we're spending some time on this one. So Tsigavatso, let's go to you first. What do you think is interesting about the tan graph?
Good afternoon, sir.
Hey.
What's interesting about the tan graph is that it has asymptotes.
Ah, yes. And where are they?
On the 90 degrees and 270 degrees.
Yes, you're right. Can you tell me about the period of the tan graph? Do you know what the period of the tan graph is?
The period of tan graph is 180 degrees.
Yes, exactly. Fantastic. So every 180 degrees, you have a new asymptote, and the asymptote you may not cross. And part of the reason tan has this funky shape is because if we think back to trigonometry earlier in the year, we know that the tan of theta is actually the sine of theta over the cos of theta. There's an identity. And so that's part of the reason why it's got this funky, it looks like a wavy thing that's, I don't know, it looks a bit different. And that's because it's made up of sine and cos. Now, the other thing I want to point out is that the earlier graphs, the sine graph and the cos graph, if we look at them, the period of these graphs is not 180. Can anybody tell me what the period of this cos graph was? What's the period of the cos graph? You can put your hand up or you can put it in the chat. So RT has said that the period of the cos graph is 360. Ando agrees. Okay, now I want to talk to you about drawing these graphs as well. When we draw the cos graph or the sine graph, we talk about something called the step size. And the step size is just the period divided by 4. And so the step size for the cos graph is going to be 90. And the step size for the sine graph is also going to be 90, because you just go 360 is the period divided by 4. And you can kind of see these steps. Like there's the first step. And like there's the second step. So when you draw these graphs, the step size is an important idea. Now, what I want to ask is, what is the step size of the tan graph? And I want you to be careful here because, yeah, it's a little bit sneaky. But what is the step size of the tan graph? So the thing that's key about the tan graph is that we don't divide, we actually divide it into 2. Even though the period is 180, and the reason the step size is 90 is that, can you see the tan graph has 2 parts? It's got the first part there and the second part there. And so its steps are divided into 2 steps, whereas the other ones will always have 4 steps within a period. It's a bit of a tricky idea. So give me a thumbs up if you understand why we divide by 2 for tan, but we divide by 4 for sine and cos. Okay, so I've definitely lost a lot of you. Let me go over that again. So if you look at the shape, okay, now I can see I have a few of you. If you look at the shape of the tan graph, when we draw it, you'll notice that it's almost like we draw that part and we draw that part. So there's like 2 parts that when we draw one period of the graph, we basically draw it in 2 pieces. So that's why we're dividing by 2 here. But if we go up to our cos graph, and let me get rid of some of this clutter, because I think some of this clutter is interfering with our understanding of what's going on here. So if you look at this graph, y equals cos of theta, when we draw it, we start here and we go down in 90. That's 1, 2, 3, 4. And so that's why we divide by 4, because we basically are dividing it into these 4 pieces that we are drawing it in. So that's why we go 360 divided by 4 to get my step size of 90. Okay, we're going to come back to this in later lessons. Today is, again, it's about laying the groundwork of what step size is. And when I think about step size, it's like the pieces that I use to draw the graph. Like if I want to draw the sine graph, my first step is like that. Second step is like that. Third step is like that. Fourth step is like that. And so it's almost like I'm taking steps to draw the graph. Whereas when I draw the tan graph, the first step goes like this. The second step goes like that. That's all I'm trying to show you. So maybe let's have another vote. Thumbs up if it's looking a bit clearer. Thumbs down if you are feeling still a bit unsure. Okay. Okay, let's do this one. What is this going to be? So what is the equation of this curve? A, B, C, or D? We could use our calculator to help us check, but some of you might recognize the shape. Okay. So the correct answer, I can see lots of students have locked this in. The correct answer is this, y equals sine x. And if you put into your calculator, let's do a little exercise. I want everyone to put 270 in your calculator and tell me what you get, and then we'll compare it to the graph and see if it makes sense. What do we get for the sine of 270? So according to your calculator, we get -1. Now, if I had to think, this is the step from 180 to here, this is going to be 270. So that's going to be one step. And what is the value of 270 in line with? It's in line with -1. So I feel happy because the algebra in your calculator and the picture is making sense. Let's do another little bit of fun on this. If I said to you, what is the sine of -180, and I want you to work this out without your calculator, what is the sine of -180 going to be equal to? This is without your calculator. Yeah, it's going to be 0. And the reason you know it's 0 is you can literally see it. You can see that that point is in line with 0. Okay, so we've covered the 3 basic graphs. And I think we're getting a bit more comfortable. So let's ask ourselves another question. If I said to you, what effect does the transformation sine of x plus 3 have on the graph of the function y equals sine x? So instead of this being, I want to know which one, what do you think happens here? Okay, there's a couple of different answers going on. What do you think this +3 does? Yeah, I see some hands are up there. Or a T-way. Let's go to you. What do you think this does?
Evening, sir.
Hello. What is the, yeah.
So can you just explain this? Because like now that we put it in words, I'm so confused. I don't know what's going on.
Okay. So the first one says moves the graph 3 units down. So that's for A. For B, it says moves the graph 3 units up. For C, it says moves the graph 3 units to the left. And for D,
Oh, okay,
it's-
sir. I
okay,
see it now. Yes, sir.
Yeah.
Thank you very much.
which one do you think it's going to be here?
See.
Who has C? Moves the graph 3 to the left. The problem is, I think that the plus, well, let's put it in our calculators. Let's see what the calculator says. So if I go and I put a 90, so I go sine of 90, and remember that's a closed thing, plus 3, what will I get? What will I get in my calculator? You can tell me. So I get 4. And normally, when I get the sine of 90, put that in your calculator. What do you get for the sine of 90? We get 1. And remember, this is a y value. Now, what does that tell us about which option we think it is? We know that the sine of 90 is 1, but the sine of 90 plus 3 is 4. What's that telling? And these are y values. So I want to know, which option do you think it is now? Is it A, B, C, or D? Aha. Now, I want more students. So since y equals sine, doesn't it have to fall on the y-axis? It does. You know what? I'm actually going to draw this graph for you now, just as a kind of little exercise. Because we're actually only going to draw graphs in the next lesson. But let me show you a little taster of what I would think this would look like. So when I want to draw trig graphs, you normally deal with this thing called the domain. And in this case, my domain is going to be 0 to 360. So I'm just going to make the step size. So I'll put 90, 180, 270, 360. And let's say that it goes up to 1 there and down to -1. Now, if this graph was just sine x, I draw it by doing this. Okay, this is, my scale is a bit out, but whatever. Like that, and like that. And this should all be in line. So let me quickly drop that down a little bit. Now, if it becomes +3, what's really happening is that everything is being moved up by 3. So I'm going to go 2, 3, 4, and I'm going to start here, and it's just going to go up, and then it's going to go down, and then it's going to go down, and then it's going to go up. And so the whole graph has just shifted up by +3. And so that's what the question is kind of showing. Okay, give me a thumbs up if that makes sense. Thumbs down if I've lost you. And notice how I'm drawing it using the step size. Okay, fantastic. Let's do one more question before we get to break time. We're making nice progress here. Let me choose this one here. Last one before the break. What effect does the transformation y equals minus cos x have on the function y equals cos x? And I'll even draw the graph of y equals cos x for you. While you think about it. So there's 90. So the north should look like this. Now, what effect does this minus sign in front have? Well, there's some hands up there. Let me have a quick look. So a couple of A's and a couple of B's. I always think the easiest way to do it is to use your calculator just to check. And we're going to talk about calculators in the next lesson. But if you put 90 into this. So you said y equals minus cos 90. Sorry, not minus, let's put naught, minus cos of 0. So minus cos of 0. So basically, I'm going from here. What value would you get from your calculator? So I think we get -1, which means this graph has to actually start here, which already tells me what axis am I reflecting over? I'm reflecting over that axis. And so I actually kind of know that that is the x-axis. And so those students who were saying that A, that is what the minus sign does. And if you have to draw it, the graph would just look like that. Okay, so basically, in graphs, we can imagine that if you change the sign, if we took this thing over here, we could also write it, we could also have written it like this. That means the same thing as this one. And we often say in functions, if you change the sign in front of the y, you reflect it over the opposite axis. So you reflect it over the x-axis. If you change the sign in front of the x, it would be the other way around. And so that's a little rule of functions that I spoke about in the last lesson, but it's awesome to come back to. Okay, everyone, it is time for a break. I've pushed you for a while, and it's now time to have a brain break. And so I want you to stand up away from your computers, make sure that your cameras are on, and let us take a moment to just shake our arms. There we go. Shake at your arms, shake at your legs. There we go. Twist a little bit. Take some nice deep breaths, whatever helps you to unwind. You don't have to do exactly what I'm doing. I like to roll my shoulders. Take some nice deep breaths. I roll my shoulders backwards, roll them forwards. I like to do this. And then let's do some circles. Go into big circles. And then change direction with big circles. Going into little circles. And then let's just do a quick shoulder stretch. Opposite arm. And go. Oh, it feels good actually. Yo, lots of clicking. And then let us do some high heart rate. So we are going to do jumping jacks because it's Monday, right? Monday, yes. So we're going to begin the week with some jumping jacks. We're going to do 20 of them. And you're going to join me in 3, 2, 1. Let's go. 2, 3, 7, 8, 9, halfway. 12, 13, 16, 17, 18, 19, and 20. And if that doesn't get your blood going, then I don't know. Because that is certainly got my heart rate up. And have a drink of water. And then once you've had a little sip of your water, see if you can solve one of these 2 Maths 24 puzzles. For those who are new today, a Maths 24 puzzle, basically what we do is we try to take all 4 numbers and we use them in a way to make 24. But you have to use each one of them and you can only use it once. And see if you can do that. So for the red one, Tando, is that what you're saying? 5 plus 7. Is it really that simple? 12. Oh, it is. Okay. Tando, you get the red one. Can you do the blue one? There is actually a yellow one too, but I'm not going to spend too much time on that. But see if you can make 24 using those numbers. Anybody got some ideas? Normally it helps to make factors of 24. So 6 and 4, if you can get to them, or 8 and 3, those can all be helpful. I was thinking if you go 8 minus 2, how does that help you? What might that be useful for? So if 8 minus 2 is 6, we've used 8 and 2. You close, Ayanda, you're almost there. So if you go 8 minus 2 is 6. What if you go 7 minus 3 is 4? Then how do we get to 24 from there? Okay, so, there we go. Klecho also agrees. So you get, and then you go, and so does Tando. So then you go 6 times 4 is 24. Okay, cool. I hope my heart rate is just about calmed down. So let's go back
Nicely
to
done, guys.
Yes, well done, everyone. Let's go to this graph over here. I want you to tell me, looking at this graph, what is the value of the cos of minus 60? What is, and you might need to use your calculator, so the cos of minus 60. Now, this is the cos graph itself. What do we think it is? Let me find minus 60. So what's this? So if this goes up 22 and a half, what's this? Where is it? So this is 10, 20, 45, 67 and a half. So I guess 60 would have to be somewhere around here. And check on your calculators. So check what, so this looks to me like it's correct. It looks to me like it should be over here. Just check on your calculators. What is root 3 over 2? I'm just curious to know what, it's definitely not 0. It's definitely not minus a half. We know that a half is 0.5. Root 3 over 2, actually, yeah, root 3 over 2 is going to be 0.7 or 0.8 something. So the correct answer would be A. Okay, that makes sense. Yeah, so it can't be because this is 0.87, which clearly is 0.87 must be like the cos of minus 10 or something. So you guys understand that. Well done. What about the value? What is the cos of 120 using this graph? So if we look here, where would 120 be? So 120 would be about over here. And that lines up with -1/2. And so the correct answer is going to be, because it's going to be negative, it's going to be C. Take a moment to see if you can understand that. So if you look on the domain, if you put 120 in, you come down to here, and you should be in line with, can you see how this is halfway down? Like this is half the way down to 1. And so the correct answer is going to be C. Yeah. Let me make up another one. If I said to you, if you had to tell me what is the value of the cos of 360? What's the value of the cos of 360? What's that going to be equal to? Yeah, because we can just see that the cos of 360 is down here, and that is in line with the 1. Yeah, you guys know what's going on here. No problem. Okay, so let's have a look at another one over here. Okay, here's something a little bit more interesting. So this goes back to what we call a trig equation. So this says the sine of x is 0.122. Okay. Now, there is something that you learned about in trig. So before we do this, I want to talk about something called the cast diagram. Can somebody come online and tell me a little bit about the cast diagram? I want to know what you remember. And I also want to know, how does the cast diagram link up to trig graphs? That's a bit of a mystery. Who feels like they know a little bit about the cast diagram? And we're also going to talk about solving basic trig equations. Okay, Oratiwe, can we unmute Oratiwe?
Okay, so basically, the cost
Yeah.
diagram, it's an acronym of cos, all,
Yeah.
sine, and tan. So basically, we use it to solve co-ratios as well as let me think, co-ratios.
Right.
Yes, sir. So basically, in quadrant. So in quadrant, the first quadrant, in quadrant
Yes.
A, all of the ratios are positive, and then in
Yes.
quadrant 2, which is sine, only sine is positive and the rest is negative. And then tan is positive there, and then the rest is negative. And then on the other side, cos is positive, and then the rest is negative.
Okay, perfect. So you've told us the cast diagrams helps us understand where trig ratios are positive and negative. There's also something called an angle. So everything in quadrant 1, we would often say it's x or it's theta. What type of angles occur in quadrant 2? Can you remember that one? Maybe we'll go to Tegavatso, has his hand up. Let's go to Tegavatso.
So on the second quadrant, it's 90 plus theta and 180 minus theta.
Okay, so I'm going to go with the 180 minus theta. What about quadrant 3?
180 plus theta.
Okay, and the last one here?
360 minus theta.
Okay, this is important. So this thing is actually linked to the graph is linked to this cast diagram here. Now, what you'll notice is this is a sine graph. And what you'll notice about the sine graph is that the sine graph is positive here, and it's also positive up to here. And then when it goes past 180, you'll notice that it's negative So it goes to 270 over there. So it's negative, and then it's negative over here. And this is what the cast diagram says. It says everything is positive and sine is positive here. And then quadrant 3, sine is negative, and this is negative here. Okay, now, in order to solve this problem in a simple way, before we even get to reference angles and stuff like that, if I wanted to visualize the sine of x equals 0.122, I'm going to go and find 0.122, and I think that that would be like, so like basically over here, because that is a positive value. So give me a thumbs up if you understand why I think that the answer is here and the answer is here. Give me a thumbs up if you feel like you understand where I'm coming from with this. Okay, now, in the next lesson, I'll talk a little bit more about the cast diagram. But for now, actually, I just want you to have a look at this drawing here. When is the sine of x equal to 0.122? And I can see I've lost, I think maybe I've distracted you with the cast diagram. So let's ignore the cast diagram for a moment. So I think maybe that was a little bit too much at once. I want you to just look at my line and say, look, the sine of x equals 0.122. Now, if you look at this line here, I think that this is how many? 1, 2, 3, 4. This is 0.25 over here, and then half of that would be about 0.122. And I've said, look, which answer do you think is correct? Do you think it's A, B, C, or D? So just ignore this part for now and just look at the drawing. If you think of this graph as y equals sine x, what do you think the answer to this is going to be? I don't think it can be A, because the 2 green dots fall before 180. I don't think it can be C. And I also don't think it can be D. Because if I look at this one, that looks like an answer, and that looks like an answer. And the correct answer is indeed B. Now, all I wanted to show you with the cast diagram is to show you that the solution to this trig equation, sine of x equals 0.122, can be visualized using a graph. You can find the solution using a graph, but the other thing is the solution can also be found using the cast diagram. And the reason the cast diagram is helpful is we know that sine is positive in this quadrant and this quadrant. And the first answer we get in this case is just going to be 7 degrees. But there's also an answer which is on the opposite side, which is just going to be 180 minus 7 degrees, which is the 173. And I was just trying to connect those two worlds. Okay, so let's finish today with just making sure we know how to draw basic trig graphs. So I want everyone to do this with me. I'm going to draw the graph of y equals sine x. I'm going to draw the graph of y equals cos x. And I'm also going to draw the graph of y equals tan x, because in the next lesson, we're going to start to play with that. And we're also going to make sure that we can do some shifts of these. So whenever we draw a trig graph, we talk about the domain. In this case, I'm going to say the domain is 0 to 360. And for this one, I'm also going to say 0 to 360. It's very helpful to know the steps And the step size here is going to be 90. The step size here is going to be 90. And for this one, the step size is going to be 90. So what do these graphs look like? Because this is what you have to carry with you to the next lesson. My basic sine graph. So we said the step size is 90, 180, 270, 360. And then I'll do the same here, 90. Okay, so then if I want to draw this graph for the sine graph, I simply go up to 1, down to 180, down to 270, and up to 360. That's my sine graph. And you can, these points over here are called the turning points. For the cos graph, I start at 1 and I go down. Notice how I'm going in these little things like that. To 180, 270, 360. That's the turning point. And then for the tan graph has asymptotes at 90 and again at 270. When I draw the graph, I draw them in halves. So this one is going to look like that. And then this part over here is going to look like that. And so as we go forward into the next lesson, we are going to talk about how do we draw these graphs using something called step size and using the period of the graph. And how do we begin to shift these graphs up or down, or how do we change the number in front of these graphs and what effect does it have? And we're also going to talk about how do I use my calculator to make life easier. Okay, that is the lesson for today. And it was just sort of a reintroduction to trig graphs. We will talk about all sorts of tricky stuff going forward. And Lebo, if you could just put the poll out, that will be awesome. Are there any final questions from based on today or anything you want to ask before we bring the lesson to a close?
Mr. Ace, we have a hand from Regan.
Yes, Regan, what is your question?
Sir,
Yes.
I'm having problems with the special angles, sir.
Okay.
Like, you know,
what part of special angles? Like,
sir.
so like knowing what sine of 30 equals? Or...
Yes, sir, like that, sir, without like using a calculator and all, sir.
Okay.
Because we drew the special angles graph or whatever you call it in class, but like I don't understand like when it gets past.
Okay, you need to memorize what's called the special triangles. I think that's the easiest way to do it. So there's two special triangles. The one special triangle has 45, 45, and 90. The other one has 60, 30. Have you seen those before? Okay, so what you need to do is if you memorize that triangle for this one, and then if you memorize these two, you simply read off the value of the special triangles. So say, for example, you say the sine of 30 is what? Well, what's opposite 30? It's going to be O, and then this is the H, and this is the A. The sine of 30 would just be O over H, or 1 over 2. Okay. Whereas if I wanted to know what the sine of 60 would be, well, then the 60 would be the thing causing the O, and this would be the A, and the sine of 60 would just be root 3 over 2. So you just have to memorize these two triangles to help you work those out. Okay, Tsegavatso, let's go to you. Your question.
So I would like to ask, like, if they say x are the elements of 0 is to maybe like 180, what happens
Yes.
to the period of the sine and the cos graphs?
Okay, so the period of the graph won't change. If they say the domain is minus 180 to 360, all that means is that the runway that you're drawing on gets longer. Okay, so like maybe it goes like this far, but then you just keep drawing using your step size. Okay, we'll talk about period change for a trig graph in lesson 3.
Okay, so thank you.